Friends, we will continue the study of complex number. Up to multiplication, in the last class we have discussed that. Now, we will continue one more operation, division of complex number. Before division, that we must try to know that one more concept in the complex number, what is conjugate of complex number. Conjugation means, suppose we know that a plus ib and another complex number a minus ib. Here a plus ib and a minus ib, they are called complex conjugate pairs of numbers. Why those are called complex conjugate pairs? Since while those numbers, while multiplying together or each other, we must get a purely a real number, then those numbers are called complex conjugate pairs of numbers. Now, here it is a plus ib into a minus ib, that is equal to, as per your algebraical rule, it becomes a square minus ib square, and that is equal to a square plus b square, because I square is minus 1. So, which is nothing but purely a real number. So, therefore, the complex conjugate of a plus ib is a minus ib, and vice versa, complex conjugate of a minus ib is a plus ib. For example, conjugate of z is equal to 3, conjugate of z is equal to 3 plus 4i is 3 minus 4i. Then conjugate of z is equal to 5 minus 4i is 5 plus 4i, and normally we will denote the conjugate complex numbers by z and its conjugate by z bar, as I have denoted there. Just observe that it is z bar refers to. Next, now we are in a position to define division of complex number. When the two complex numbers are divided, the two complex numbers are divided by dividing the conjugate pair of denominator that I have given and multiplying each term by term. Say for an example here, 1 minus 3i divided by 1 plus 2i. How to divide those two numbers? Now, you take the conjugate of denominator as I have given the rule. Conjugate of 1 plus 2i denominator is 1 minus 2i divided by same term 1 minus 2i. And now, next step here, you multiply numerator and you multiply denominator. The multiplication is as usual as I have defined there. On simplification, you will get, I have given all the steps there elaborately. Just go through all the steps, because it is an elementary steps, you can catch up those ideas, and the resultant is going to be here minus 1 minus I. Observe it properly. Next, one more concept that we are going to define, it is modulus of complex numbers. Modulus is, suppose if z is equal to a plus ib, then modulus of z is, we will denote in two parallel bars. Say as I have defined there, as I have denoted there, mod z is equal to root of square root of a square plus b square. For example, if z is equal to 1 plus 2i, then mod z is equal to square root of real part square 1 square plus imaginary part square, it is 2 square, it is equal to root 5. Similarly, one more example, z is equal to 3 minus 4i, then mod z is equal to square root of 3 square real part square plus, here imaginary part is minus 4, it becomes minus 4 whole square. The resultant is going to be 3 square is 9 and 4 square is 16, 16 plus 9 is 25, square root of 25 is 5. So, hence we can find out the modulus of complex number now as I have defined there. And geometrically, what it represents modulus here? Geometrically, it represents distance of the number from the origin. Now, here origin is 0, 0 is equal to 0 plus I into 0. So, geometrically modulus represents distance function. Now, see there are properties here, modulus of complex number, that is real z is equal to z plus z bar divided by 2. That means, z is equal to a plus ib plus z bar is a minus ib. While adding those two number, imaginary part ib cancels, it gives you 2a divided by 2, it is nothing but a, that means real part only. Similarly, while subtracting those two numbers and divided by 2, it gives you imaginary part only, and this is the properties, you keep it in mind. Next, as here there is an privilege to write a complex number in more than one form. A complex number z is equal to a plus ib, or it is also denoted x plus iy. It is called Cartesian form of complex number. We can denote the Cartesian form in more than one form, and that is only possible in complex number, and that is called polar form of a complex number. Now, how to write polar form of a complex number? If you are given z is equal to x plus iy, then the polar form of this is, we can write it as r into cos theta plus I sin theta, or in short we can write r into cis theta. What is that r represents? R is equal to modulus of the complex number, and that is equal to square root of x square plus y square if you are taken in terms of x plus iy, or r is also equal to write root of a square plus b square if you have taken a complex number z is equal to a plus ib, and theta is called amplitude or argument of the complex number, and the argument is defined it as theta is equal to tan inverse of y by x. We can find out complex number in more than one form, and that is polar form. For example, if you are given z is equal to 1 minus I root 3, see, keep it in mind, this is in Cartesian form. How to convert into polar form? As I have given to you the form 1 minus I root 3, we can write it as r into cos theta plus I sin theta. Here you have to find out r. Now, r is equal to here square root of 1 plus minus I root 3 whole square, and on simplification it becomes square root of 1 plus 3, it is nothing but root 4, it is equal to 2. So, therefore, we will get r is equal to 2. And how to find theta here? As I have defined, theta is equal to tan inverse of y by x. Now, here you have to keep it in mind to find out amplitude or argument. If theta lies in the first quadrant, it is going to be theta is equal to tan inverse of y by x. If the given number is in the second quadrant, it is nothing but theta is minus tan inverse of y by x. Similarly, third quadrant, similarly fourth quadrant, different formulas available. Now, here as the number lies in fourth quadrant, theta is equal to minus tan inverse of y by x, y term is root 3 and x term is 1, it is tan inverse of minus root 3, it is nothing but in the fourth quadrant, it is minus pi by 3. Therefore, 1 minus I root 3 is equal to 2 into cos minus pi by 3 amplitude plus I sin minus pi by 3. Thank you. We will meet in the next class.